So here's a visualization that is similar to the one that I did for the parabola, except it's for the ellipse. But because it's the ellipse, it's a little bit more complicated. So let me just explain the different pieces one by one. So when you come in, you have an ellipse, and it's centered at the origin, and all the ellipses in this visualization will be centered at the origin. The red dot is one of the foci, so I'm only going to include one of them. And you can drag that, and that will change the size of the ellipse. So I have it set up that you can drag this particular focus out to about 5 or so. Notice that this line here, which is the directrix, is tied to the position of this focus. All right. Now notice that the shape of all the ellipses is the same. They're just larger as you move the focus. To change the shape, you can move this slider up here, the green point, and that represents what's called the eccentricity of the ellipse. If you move this to the right, it makes the ellipse flatter. Notice that the position of the directrix is also tied to the eccentricity. So once you have the focus and the eccentricity set, then the directrix is set. Now the eccentricity, so we will not go above 1 here, because if we went above 1, we would not have an ellipse anymore. And I limited it to 0.7 because as you move more towards the left, the ellipse becomes more circular. But I wanted to keep everything on screen here, so it was kind of hard to do that for the full range. So I thought this was sufficient. Okay, so that's how you can set up the particular ellipse that you want to work with. All right. Then I also have the white dot like I had before, and that can be moved anywhere. And once again, you can visualize the distance of the white dot to the directrix and to the focus. The question is, what should the relationship be between the length of the red segment and the length of the blue segment for this white dot to be on the ellipse? So over here I have a gauge similar to what I had for the parabola. Now if these are of equal length, let's see if I can get that right about there. If these are of equal length, then the red segment and the blue segment will line up at 0.5 over here. If you took their ratio, if you take red over blue, right, that would be 1. And that was the case for the parabola, exactly 1. For an ellipse, you want that ratio to be less than 1. And that ratio is the eccentricity. Okay, so here we have an ellipse that has eccentricity of 0.7. That means the ratio of the red to the blue length should be 0.7 if this white dot is to be on the ellipse. And I have marked here a green bar when that's achieved. So when the length of the red bar comes up to the, in other words, when the blue and the green and the red meet here at the green, that means the ratio of the red to the blue length here and over here is what is indicated up here by the eccentricity. So right now the length of the red is too long. So if I move that down, it should, right when I hit the ellipse, meet at the green. And that is the idea. So it should give students, it's a little bit more complicated, but it should give students an idea of how to define an ellipse with focus and directrix. Now you shift here, and of course you're going to be off a little bit, And when you return to the ellipse, you meet right at the green. So there it is for the ellipse, and I can do one more of these for the hyperbola.